The morning sun barely penetrated the grimy windows of the industrial district warehouse, casting long shadows across decades of accumulated dust and forgotten machinery. The building stood silent among its neighbors, a relic from an era when American manufacturing dominated the landscape and diesel engines powered the nation's commerce. Inside, beneath layers of neglect and abandonment, something extraordinary waited in the darkness. Walter Brennan had spent 53 years working with engines. His calloused hands bore the permanent stains of motor oil and hydraulic fluid, decorative scars that told stories of countless repairs, rebuilds, and resurrections. At 72 years old, most men would have retired to quieter pursuits, but Walter's passion for mechanical symphonies burned as intensely as the day he first opened a toolbox. His small independent shop operated on the outskirts of town, a modest establishment where locals brought their troubled vehicles and trusted the old mechanic's encyclopedic knowledge. The warehouse discovery happened by accident, as most remarkable findings do. Walter had been searching for parts to complete a restoration project when a contact mentioned the abandoned facility. The property owner wanted everything cleared before demolition crews arrived in 3 months. Most salvagers had already picked through the obvious treasures, leaving behind what they considered worthless scrap. Walter arrived on a Tuesday morning with modest expectations and a pickup truck, prepared to spend a few hours sorting through industrial refuse. The warehouse interior resembled an archaeological site, layers of manufacturing history stacked haphazardly across concrete floors. Rusted machinery formed mechanical mountains, their purposes obscured by decades of deterioration. Walter methodically worked through the chaos, his experienced eyes identifying valuable components amid the wreckage. Transmission casings, hydraulic pumps, drive shafts, and countless other mechanical organs filled his truck bed as the morning progressed. Then he found it. The discovery occurred in the warehouse's furthest corner, where shadows pooled deepest and daylight surrendered completely. A massive tarp covered something substantial, its canvas fabric stiff with age and covered in bird droppings. Walter approached cautiously, his mechanic's intuition sensing significance beneath the concealment. He grabbed the tarp's edge and pulled, the ancient canvas disintegrating in his hands as he revealed what lay beneath. The V12 Detroit Diesel sat majestically on a reinforced steel mounting stand, an engineering masterpiece frozen in time. Even through the corrosion and neglect, Walter recognized the engine's legendary design immediately. Detroit Diesel's two-stroke V12 configuration represented the pinnacle of American diesel engineering, a powerhouse that once propelled heavy machinery, marine vessels, and industrial equipment across the continent. This particular specimen appeared to be a custom-built variant, modifications and upgrades suggesting someone had invested enormous resources into maximizing its already formidable capabilities. Walter circled the engine slowly, his flashlight beam revealing details that made his heart accelerate. The displacement appeared massive, likely exceeding the standard configurations he'd encountered in service manuals. Custom-machined cylinder heads featured reinforced casting and enlarged ports. The fuel injection system incorporated components he'd never seen on production models. Massive turbochargers flanked both banks, their housings bearing manufacturer stamps from obscure European specialists. Someone had transformed this engine from impressive to extraordinary, pursuing power levels that challenged conventional wisdom and engineering prudence. The mechanic's hands trembled slightly as he touched the cold metal, decades of accumulated grime coating every surface. Corrosion bloomed across chrome components once polished to mirror finishes. Rubber seals had deteriorated into brittle fragments. Electrical connections showed green oxidation spreading like cancer through the wiring harness. Condensation and temperature cycles had left their mark everywhere, nature slowly reclaiming what humans had abandoned. Before you go any further into this incredible journey, this channel is incredibly close to hitting 6,000 subscribers, and your support would mean absolutely everything. If you're enjoying stories about mechanical resurrection and engineering passion, smash that subscribe button right now and consider leaving a super thanks to help keep these detailed documentaries coming. Also, drop a comment letting me know where in the world you're watching from. I love hearing from fellow enthusiasts across the globe. Now, back to Walter and his incredible discovery. Despite the deterioration, Walter's experienced assessment suggested the engine remained salvageable. The block showed no obvious cracks or catastrophic damage. Pistons moved when he manually rotated the crankshaft, indicating the internals hadn't seized completely. The fuel system appeared intact, though obviously requiring complete rebuilding. Most importantly, the fundamental engineering remained sound, providing a solid foundation for restoration. Walter spent the remainder of that day documenting everything. His smartphone camera captured hundreds of photographs from every conceivable angle, recording the engine's condition for future reference. He measured critical dimensions, noting specifications that would guide parts acquisition and rebuilding decisions. His notebook filled with observations, questions, and preliminary planning notes. The warehouse's impending demolition created urgency, but rushing such a significant undertaking would guarantee failure. The logistics of moving the V12 presented immediate challenges. The engine's weight exceeded 2 tons, possibly approaching 3 with the mounting stand included. Walter's pickup truck couldn't manage such mass, requiring professional equipment and careful planning. He arranged for a friend's flatbed truck and borrowed an engine hoist from another contact, scheduling the extraction for the following weekend when sufficient manpower could be assembled. That evening, Walter researched everything available about Detroit Diesel V12 engines. The Internet provided technical specifications, service bulletins, and enthusiast forums where diesel fanatics debated arcane details. The standard configurations produced between 450 and 650 horsepower depending on application and tuning. However, the modifications Walter had documented suggested this particular engine targeted much higher output, potentially approaching or exceeding 900 horsepower. Such power levels demanded exceptional component strength and precise assembly, pushing every element near its material limits. The research also revealed why someone might abandon such a valuable engine. Detroit Diesel two-stroke designs, while legendary for reliability and power, had become increasingly regulated out of existence. Emission standards and fuel efficiency requirements made the old screaming demons impractical for most applications. Parts availability declined as manufacturers discontinued production. The expertise required for proper maintenance became increasingly rare. The engine Walter discovered likely represented someone's abandoned dream project, too valuable to discard but too impractical to complete. Sleep came reluctantly that night. Walter's mind churned through technical challenges and restoration strategies, excitement warring with pragmatic concerns about time, money, and physical capability. Bringing the V12 back to life would test everything he'd learned across 5 decades of mechanical work. Success would create something magnificent, a functioning monument to American engineering excellence. Failure would consume resources and leave him with an expensive pile of scrap metal. Saturday morning arrived with perfect weather, clear skies and moderate temperatures ideal for heavy mechanical work. Walter reached the warehouse early, conducting final preparations before the crew arrived. The extraction required precision and patience, any mistakes potentially damaging the engine or injuring someone. He'd mentally rehearsed every step throughout the week, identifying potential problems and developing solutions. 3 friends arrived shortly after dawn, each bringing specialized skills and equipment. Marcus operated heavy machinery professionally and understood load dynamics and balance points. Thomas worked construction and possessed extensive rigging experience. Raymond owned an automotive restoration business and regularly moved engines and transmissions. Together, they represented decades of combined expertise in handling substantial mechanical components. The group conducted a thorough assessment before beginning. The mounting stand included lifting points designed for exactly this purpose, strong attachment points where chains or straps could be secured safely. However, decades of corrosion had weakened metal components unpredictably. They supplemented the original lifting points with additional support, distributing forces across multiple connections to prevent catastrophic failure. Marcus positioned the engine hoist carefully, its wheeled base navigating between warehouse debris. The device's hydraulic arm extended toward the V12, chains descending to the connection points. Each chain received inspection and testing before bearing weight, safety paramount throughout the operation. Thomas climbed onto the mounting stand, securing connections while Raymond steadied the chains from below. The initial lift proceeded gradually, hydraulic pressure raising the massive engine millimeter by millimeter. Metal groaned and creaked as forces redistributed through aged components. Everyone maintained vigilant attention, watching for signs of impending failure. The chains stretched taut, taking the engine's full weight as the mounting stand supports cleared their resting position. Moving the suspended V12 required coordinated effort and constant communication. Marcus operated the hoist controls while the others guided the swinging mass, preventing collisions with warehouse obstacles. The journey toward the loading dock proceeded slowly, each meter requiring careful navigation. Doorways barely accommodated the engine's width, necessitating precise positioning and multiple adjustments. The flatbed truck waited in the loading area, its bed positioned at optimal height for receiving the mechanical cargo. Wooden blocking had been arranged to cradle the engine securely during transport, preventing shifting or tipping. Marcus maneuvered the hoist into position, aligning the suspended V12 above its transportation cradle. Lowering the engine tested everyone's nerve. The descent required absolute control, any sudden movements potentially damaging components or causing the engine to roll. Hydraulic pressure decreased gradually, the chain slackening as the V12's weight transferred to the wooden supports. Metal contacted wood with definitive thuds, the blocking compressing slightly under the tremendous mass. Securing the cargo consumed another hour. Heavy straps wrapped around the engine at multiple points, each cinched tight and double-checked. The goal wasn't merely preventing the engine from falling off the truck, but ensuring it remained absolutely stationary regardless of road conditions or emergency maneuvers. Additional blocking wedged between the V12 and the truck bed sides, eliminating any possibility of lateral movement. The convoy departed the warehouse mid-morning, proceeding cautiously toward Walter's shop. Speed limits received religious observance, the precious cargo demanding careful handling. Every bump and turn required advance planning, the driver maintaining smooth inputs that prevented sudden forces from challenging the securing straps. Walter followed in his pickup truck, simultaneously thrilled and anxious about the mechanical treasure being transported ahead. The shop's overhead door opened wide, revealing the workspace Walter had spent the previous evening preparing. The garage's interior had been reorganized extensively, clearing maximum floor space for the massive engine. Tool cabinets had been relocated, project vehicles temporarily moved outside, and cleaning conducted with unusual thoroughness. A heavy-duty engine stand waited in the designated position, ready to receive the V12 once unloaded. Transferring the engine from truck to stand reversed the extraction process, requiring the same careful rigging and controlled movements. The shop's overhead crane handled the lift, its capacity rated well above the engine's weight but nonetheless operating near the upper limits of its design specifications. The mechanical ballet proceeded smoothly, experience and planning eliminating surprises. Finally, the V12 sat securely in Walter's shop, ready for the long restoration journey ahead. The crew celebrated with cold drinks and shared satisfaction, the successful extraction representing a significant accomplishment. They departed gradually, leaving Walter alone with his acquired project. He stood before the massive engine, contemplating the enormous challenges awaiting his attention. The following days involved comprehensive documentation and analysis. Walter systematically photographed every component, creating a visual record that would prove invaluable during reassembly. His measuring tools confirmed dimensions and clearances, verifying specifications against available technical documentation. Each discovery raised new questions while occasionally providing encouraging answers. The engine block showed remarkable condition despite the cosmetic deterioration. The cast iron had resisted corrosion's worst effects, maintaining structural integrity throughout the abandonment period. Walter tapped various locations with a small hammer, listening for the distinctive sound of solid metal versus cracked or damaged material. The responses suggested the foundation remained sound, an essential prerequisite for successful restoration. Removing the valve covers revealed the cylinder head's internal condition. Walter expected extensive corrosion and damage from moisture accumulation, but the actual state proved surprisingly favorable. Someone had apparently prepared the engine for storage, coating critical surfaces with protective compounds before abandonment. The preservation hadn't been perfect, but it had prevented catastrophic deterioration. The pistons presented greater concerns. Visual inspection through the cylinder ports revealed scoring on several skirts, evidence of previous operation under extreme conditions. The rings showed were consistent with high-power applications, their sealing surfaces degraded by combustion pressure and thermal cycling. Complete piston replacement seemed inevitable, though sourcing appropriate components for such a specialized engine would challenge even Walter's extensive parts network. The crankshaft rotation felt relatively smooth, suggesting the main and rod bearings hadn't completely destroyed themselves. However, bearing clearances certainly exceeded specification after decades without proper lubrication. The rotating assembly would require complete disassembly, thorough cleaning, precision measurement, and selective replacement of worn components. The crankshaft itself might need grinding to restore journal surfaces to acceptable condition. The turbocharger investigation produced mixed results. Both units showed obvious bearing damage, their compressor and turbine wheels rotating with noticeable play. The housings remained intact without cracks or serious erosion, suggesting they could be professionally rebuilt rather than replaced entirely. However, finding specialists capable of servicing such unusual turbochargers might prove difficult and expensive. The fuel injection system represented one of the restoration's most critical challenges. Detroit Diesel two-stroke engines relied on precise fuel delivery timing and quantity, the injectors functioning in concert with the supercharger to achieve proper combustion. The system discovered on this V12 incorporated aftermarket components and custom tuning, modifications that enhanced performance but complicated restoration. Each injector required testing and rebuilding, the pumps needed calibration, and the entire system demanded precise synchronization. The electrical system appeared largely intact but completely non-functional. Decades had transformed copper wiring into green-crusted conductors, the oxidation penetrating deep into cable cores. Every connection point required cleaning or replacement. The engine's instrumentation and control modules showed similar deterioration, their circuit boards corroded and components damaged by moisture. Modern replacements might substitute for some elements, but maintaining the engine's original character required sourcing period-correct components whenever possible. Walter compiled his findings into a comprehensive restoration plan, breaking the project into manageable phases. The first stage involved complete disassembly, cleaning every component while documenting original positions and configurations. The second phase focused on parts acquisition, locating replacement components through suppliers, salvage yards, and specialist manufacturers. The third stage comprised rebuilding and machining, restoring components to specification through various processes. The final phase involved reassembly, testing, and tuning, the moment of truth when the engine would either roar to life or reveal fatal flaws. The estimated timeline stretched across many months, possibly exceeding a year depending on parts availability and unforeseen complications. The budget remained difficult to predict precisely, but Walter allocated funds conservatively, expecting expenditures to climb as the project progressed. His retirement savings could absorb reasonable costs, but financial discipline would prevent the restoration from consuming resources needed for daily life. Disassembling the V12 began on a Monday morning, Walter approaching the task with methodical precision. Each component received careful attention during removal, the sequence documented through photographs and detailed notes. Organization proved essential, the sheer quantity of parts threatening to create chaos without disciplined management. The peripheral components came off first, accessories and systems that attached to the engine's exterior. The turbochargers disconnected after removing numerous clamps and bolts, their considerable weight requiring careful handling. The exhaust manifolds followed, cast iron assemblies corroded but serviceable. The intake plumbing separated in sections, revealing the Roots-type supercharger nestled between the cylinder banks. The supercharger removal required special attention, this component representing a defining characteristic of Detroit Diesel two-stroke designs. The positive displacement blower forced air through the engine, enabling the two-stroke cycle's operation while providing boost for enhanced power output. Walter inspected the rotors carefully, finding wear consistent with extensive operation but no catastrophic damage. The housing showed corrosion requiring attention but remained structurally sound. Removing the cylinder heads exposed the engine's internal geography completely. The heads themselves were substantial aluminum castings, their weight requiring assistance from the overhead crane. Walter inspected each carefully, checking for cracks or erosion that would necessitate replacement or extensive repair. The casting integrity appeared adequate, though the valve seats showed wear and several valves displayed damage requiring replacement. The pistons emerged one by one, extracted after careful rotation positioned each at top dead center. Walter numbered every component meticulously, maintaining correspondence between pistons, rods, and cylinders to preserve original relationships. The connecting rods showed signs of extreme loading, slight deformation visible near the beam centers. Replacement seemed prudent given the power levels this engine targeted. The crankshaft extraction represented a milestone moment, this massive forged steel component being the engine's literal and figurative centerpiece. The crane lifted carefully as Walter and a helper guided the shaft free from the block. Horizontal mounting on padded supports allowed comprehensive inspection, Walter examining every journal surface for scoring, cracks, or geometric irregularities. The damage appeared manageable, precision grinding likely sufficient to restore the journals to specification. With the major components removed, Walter focused on smaller elements requiring attention. The oil pump disassembled into constituent parts, each cleaned and measured against specifications. The water pump received similar treatment, its impeller and housing showing corrosion but remaining serviceable after refurbishment. Countless seals, gaskets, and fasteners went into organized containers, sorted by location and function. The engine block stood empty now, its internal passages exposed for thorough cleaning and inspection. Walter pressure washed the exterior, decades of accumulated grime dissolving under the chemical cleaner and high-pressure water. The interior received similar attention, every oil passage and coolant channel flushed repeatedly until the runoff emerged clear. Compressed air dried everything thoroughly, preventing new corrosion from forming in the clean passages. The block inspection revealed no catastrophic flaws. The cylinder walls showed expected wear patterns, requiring boring and honing to accept oversized pistons. The main bearing journals appeared acceptable, their surfaces requiring minimal preparation. The deck surfaces needed resurfacing to ensure proper head gasket sealing. Overall, the foundation proved sound, justifying the restoration effort. Sourcing components for such a specialized engine tested Walter's extensive parts network thoroughly. Standard Detroit diesel components could be located through traditional suppliers, but the custom modifications required creative solutions and persistent searching. The quest consumed weeks, countless phone calls and internet searches gradually producing results. The piston procurement proved particularly challenging. Standard Detroit Diesel V12 pistons wouldn't withstand the power levels this engine targeted, necessitating custom forgings designed for extreme applications. Walter eventually located a specialist manufacturer who produced racing pistons for marine applications. After extensive consultation and dimensional verification, an order was placed for custom pistons featuring enhanced strength and optimized geometry. The connecting rods followed a similar path. The original rod's deformation suggested replacement rather than refurbishment, but finding suitable substitutes required significant research. A company specializing in heavy-duty diesel racing eventually provided appropriate components, forged steel rods featuring adequate strength margins and precise machining. The turbocharger rebuilding proceeded through a specialist located several states away. Walter shipped both units carefully packaged, accompanied by detailed descriptions of the engine application and performance requirements. The rebuild consumed several weeks, new bearings and seals replacing damaged components while the housings received inspection and minor repairs. The returned turbochargers arrived looking nearly new, their performance specifications verified through testing. The fuel injection system proved most problematic. The custom components installed by the engine's original builder incorporated proprietary modifications and tuning that couldn't be replicated without extensive reverse engineering. Walter eventually located a diesel performance specialist with experience tuning similar systems. The collaboration involved shipping components for analysis, extensive phone consultations, and ultimately a complete rebuild with modern equivalents that would deliver similar performance characteristics. The electrical system restoration took a different approach. Rather than sourcing original components, Walter decided to implement modern equivalents that would provide improved reliability while maintaining appropriate aesthetics. New wiring harnesses were fabricated using period-correct cloth covering over modern conductors. The instrumentation incorporated rebuilt original gauges supplemented with discrete additional sensors that would provide comprehensive monitoring during testing. Gaskets and seals required complete replacement throughout. Some components were available through standard suppliers, but others required custom fabrication. Walter worked with a gasket manufacturer to produce head gaskets designed for the enhanced power output, using modern materials that offered superior sealing under extreme conditions. The accumulating costs tracked somewhat higher than initial estimates but remained manageable. Walter's careful budgeting and willingness to invest personal labor rather than paying for professional services at every stage kept expenditures reasonable. The project represented a significant financial commitment, but the investment seemed justified by the unique result it would produce. The engine block traveled to a machine shop specializing in performance diesel work, their equipment and expertise essential for the precision operations required. The boring process enlarged each cylinder by carefully calculated amounts, removing damage while maintaining proper geometry. The machinist used precision measuring equipment after each pass, advancing gradually toward the target dimensions. The finished cylinders showed mirror-smooth surfaces with correct geometry and consistent sizing across all 12 bores. The honing operation followed boring, this process imparting the specific surface finish that would retain oil while allowing proper piston ring sealing. The crosshatch pattern created during honing served critical functions, providing pathways for lubrication while maintaining dimensional accuracy. The machinist verified the finish using specialized gauges, ensuring conformance to specifications. The block's deck surfaces received precision milling, removing corrosion and irregularities while restoring the flat planes essential for head gasket sealing. The operation removed minimal material, just enough to achieve proper surface condition without significantly altering compression ratios or valve timing relationships. The crankshaft grinding restored the journal surfaces to specified dimensions and finish. The process removed damaged material while maintaining the shaft's critical balance and geometry. After grinding, the crankshaft received dynamic balancing, high-speed rotation revealing any remaining imbalances that were corrected through selective material removal. The cylinder heads underwent comprehensive refurbishment. New valve seats were installed using interference fits and precise machining to ensure concentricity with valve guides. The valve guides themselves received replacement, worn bronze components extracted and new guides pressed into place. The port surfaces were smoothed and matched to gasket openings, optimizing airflow without compromising structural integrity. The valves required replacement throughout, the original components showing damage and wear beyond acceptable limits. New stainless steel valves provided enhanced durability and heat resistance appropriate for high-performance applications. Each valve received precise lapping to its corresponding seat, achieving the tight seal essential for compression retention and proper combustion. The connecting rods underwent detailed inspection and preparation before installation. Each rod was weighed precisely, the lightest becoming the target weight for all others. Material was carefully removed from heavier rods, achieving weight consistency that would prevent vibration and uneven loading. The big end bearings received installation with precise clearances, measured using plastigauge and micrometers. Reassembly commenced on a crisp autumn morning, Walter approaching the task with reverent focus. The clean block sat ready on the engine stand, its machined surfaces protected by light oil coating. Every fastener had been inspected and replaced as necessary, torque specifications verified against multiple sources. The assembly sequence followed Detroit Diesel's original procedures modified appropriately for the custom components. The crankshaft installation required careful handling, the massive component lowered into the block's main bearing saddles. Walter installed the bearings with meticulous attention to orientation and lubrication, the precision fits critical for proper operation. The main caps received torquing in specified sequence and stages, the bolts stretched to exact specifications that achieved proper clamping force. The piston installation proceeded cylinder by cylinder, each assembly receiving individual attention. The rings were installed carefully, gaps positioned according to specifications that prevented alignment and potential sealing compromise. Ring compressors squeezed the assemblies to cylinder bore diameter, allowing insertion without damaging the precision-machined rings. Gentle tapping with a rubber mallet drove each piston downward until the connecting rod reached its journal. With all pistons installed, Walter rotated the crankshaft manually, feeling for any binding or irregular resistance. The smooth rotation confirmed proper clearances and alignment, an encouraging indication that the internal assembly had been executed correctly. The cylinder heads came next, heavy aluminum castings requiring the crane for positioning. Head gasket installation demanded precise placement and cleanliness. Walter cleaned the block deck surfaces meticulously, removing any oil residue that might compromise sealing. The new gaskets positioned exactly over the dowel pins, ensuring perfect alignment between all passages and sealing surfaces. The heads lowered carefully, their substantial weight requiring controlled descent to avoid damaging the gaskets. The head bolt torquing followed explicit specifications, sequence and torque values critical for achieving uniform clamping force. Walter used a calibrated torque wrench, advancing through multiple stages that gradually brought the bolts to final specification. The process stretched the bolts elastically, creating clamping force that would maintain seal integrity despite combustion pressures and thermal cycling. The valve train assembly proceeded next, followers and pushrods installed with careful attention to lubrication and positioning. The rocker arms mounted on their respective shafts, adjustment mechanisms verified for proper operation. Valve lash settings required individual adjustment, each valve receiving precise clearancing that would ensure proper opening and closing timing. The supercharger installation returned a distinctive visual element to the engine. The blower mounted between the cylinder banks, its drive gear meshing with the crankshaft's corresponding component. Walter verified the backlash carefully, ensuring smooth operation without binding or excessive clearance. The intake plumbing connected to the supercharger discharge, routing pressurized air to both cylinder banks. The turbochargers mounted to their respective manifolds, the substantial units secured with high-strength fasteners. The exhaust plumbing required custom fabrication, stainless steel tubing bent and welded to create proper passages from manifolds to turbocharger inlets and from turbine outlets to atmosphere. The intake ducting similarly required careful routing, connecting ambient air sources to compressor inlets. The fuel injection system installation tested Walter's patience thoroughly. Each injector required precise positioning and timing, the adjustments critical for achieving proper fuel delivery. The high-pressure fuel lines connected between pump and injectors, every fitting tightened to exact specifications. The entire system received multiple verification checks, Walter confirming proper operation before proceeding. The electrical system came together gradually, new wiring harnesses routing through the engine bay while connecting numerous sensors and control modules. Walter labeled everything meticulously, creating documentation that would simplify future troubleshooting. The instrumentation mounted in a temporary control panel, gauges and switches arranged logically for the testing phase ahead. The preparation for the initial start attempt consumed several days. Walter filled the cooling system with appropriate mixture, bleeding air from the passages to prevent trapped pockets. The fuel system received similar attention, prime pumps forcing diesel through lines and injectors while purging air that would prevent proper operation. The lubrication system was pre-filled, fresh oil flooding passages and coating bearings before the engine experienced any rotation under power. A comprehensive pre-start inspection verified everything one final time. Fasteners received torque verification, electrical connections tested for continuity, Fluid levels confirmed adequate. Walter enlisted 2 friends as observers, their additional eyes providing safety redundancy during the critical test. Fire extinguishers stood ready nearby, safety equipment positioned for immediate access. The starting system consisted of an industrial-grade electric motor connected to the engine's flywheel, providing cranking power sufficient for the massive V12's compression. Walter positioned himself at the temporary control panel, hands hovering near switches and emergency shutoff. He took a deep breath, steadying his nerves before the moment of truth. The starting motor engaged with mechanical authority, the electric unit straining against the engine's resistance. The V12 rotated slowly, compression forces resisting motion as pistons climbed toward top dead center. The sound echoed through the shop, metallic grinding accompanied by the whine of the starting motor. The crankshaft completed 1 revolution, then another, mechanical components cycling without ignition. Walter activated the fuel system, allowing diesel to flow toward the injectors. The engine continued cranking, cylinder after cylinder compressing air while awaiting the fuel delivery that would enable combustion. The starting motor labored, its duty cycle approaching maximum safe duration. Still the V12 refused ignition, mechanical motion continuing without the transformation to self-sustaining operation. The attempt concluded after 30 seconds, Walter shutting down the starting system before damaging the electric motor. Silence returned to the shop, broken only by the clicking of cooling metal and Walter's disappointed sigh. The non-start wasn't entirely unexpected, complex engines rarely achieving immediate success, but the disappointment felt acute nonetheless. The diagnostic process began immediately. Walter checked fuel pressure at various points, confirming adequate delivery to the injectors. He verified injection timing using a specialized tool, finding the settings matched specifications. The electrical system received scrutiny, ignition circuits tested for proper operation. No obvious problems revealed themselves, the mystery of the non-start remaining unsolved. A second attempt later that day produced identical results, the engine cranking enthusiastically but refusing to fire. Walter's frustration mounted, decades of experience seemingly insufficient against the V12's stubbornness. He forced himself to step back, recognizing that exhaustion and disappointment were clouding his judgment. Fresh perspective would be essential for identifying the problem. The solution emerged during a midnight epiphany, Walter jolting awake with sudden understanding. The fuel injection timing, while matching specifications for standard Detroit diesel configurations, failed to account for the custom turbocharger installation and modified port timing. The engine required different injection timing to achieve proper combustion phasing with the altered airflow characteristics. Morning couldn't arrive quickly enough. Walter reached the shop before dawn, immediately implementing the timing adjustments his nighttime revelation suggested. The modifications involved rotating the fuel pump's drive coupling, advancing injection by several degrees relative to crankshaft position. The change seemed minor but could prove transformative for combustion initiation. The revised starting attempt proceeded with cautious optimism. The starting motor engaged, the V12 beginning its familiar rotation. Fuel pressure climbed as the system pressurized. The crankshaft completed 1 revolution, compression building in each cylinder sequentially. Then another revolution, mechanical processes cycling without result. Suddenly, a cylinder fired. The combustion was unmistakable, a sharp pressure spike interrupting the engine's smooth resistance. Then another cylinder joined, then several more in rapid succession. The V12 lurched against the starting motor, mechanical rhythm transforming as combustion began contributing to rotation. The sound changed dramatically, grinding replaced by the distinctive staccato of diesel ignition. Walter's hand trembled as he reduced starting motor engagement, allowing the engine to assume self-sustaining operation. The V12 continued firing, cylinder after cylinder joining the combustion process. The idle remained rough, several cylinders misfiring intermittently, but the fundamental transition had occurred. The engine ran under its own power, decades of silence finally broken. The sound built gradually as more cylinders achieved consistent firing. The mechanical symphony grew from uncertain staccato to increasingly confident rhythm. The supercharger began contributing, its characteristic whine rising as rotational speed increased. Exhaust smoke billowed from the open pipes, white vapor from unburned fuel gradually transitioning to the characteristic haze of proper diesel combustion. Walter maintained the idle at minimal speed, resisting the temptation to increase throttle prematurely. The engine needed time to establish proper lubrication, internal components requiring thorough oil coating before experiencing significant loading. The temperature gauges began registering, confirming coolant circulation through the passages. Oil pressure stabilized at appropriate levels, the lubrication system performing as designed. The rough idle gradually smoothed as the engine warmed. Cylinders that initially misfired began contributing consistently, the combustion synchronization improving with temperature increase. The mechanical noises also evolved, initial clattering diminishing as thermal expansion brought clearances to optimal specifications. After 20 minutes of patient warm-up, the V12 settled into surprisingly smooth operation. Walter gradually increased engine speed, the throttle advancing carefully while he monitored every gauge and listened for any distressing sounds. The response was immediate and authoritative, the massive engine accelerating with impressive eagerness. The supercharger whine intensified, turbochargers beginning to contribute as exhaust energy increased. The sound transformed from diesel rumble to mechanical scream, the characteristic that had earned these engines their "Screaming Demon" nickname. The power was visceral even at moderate speeds. The engine stand transmitted vibrations through the shop floor, tools rattling in their cabinets and windows resonating sympathetically. Walter's grin widened involuntarily, the successful resurrection producing euphoria that justified every hour and dollar invested. The V12 lived again, its mechanical voice declaring triumph over abandonment and decay. The successful start represented a milestone but not completion. Extensive tuning remained necessary to achieve the engine's full potential while ensuring reliable operation. Walter approached this phase methodically, making incremental adjustments while carefully monitoring results. The fuel injection timing required fine-tuning across the entire RPM range, optimization needed for both idle stability and peak power operation. Walter used a dynamometer-style load bank to apply controlled resistance, allowing sustained operation at various speeds while preventing runaway acceleration. He adjusted timing at multiple points, creating a curve that balanced power output against combustion efficiency and emissions characteristics. The turbocharger boost control demanded careful attention. The custom wastegate controllers required calibration to prevent overboosting while maximizing performance. Walter installed temporary boost gauges visible from the control panel, monitoring pressure levels as he adjusted wastegate springs and actuation points. The goal was achieving approximately 30 psi of combined boost from supercharger and turbochargers, a level that would enable extraordinary power while maintaining reasonable safety margins. The air-fuel ratio adjustments consumed many hours of careful work. Too much fuel produced excessive smoke and wasted energy while building carbon deposits. Insufficient fuel leaned the mixture dangerously, risking piston damage from excessive combustion temperatures. Walter installed wideband oxygen sensors in the exhaust streams, using their readings to guide fuel quantity adjustments across the operating range. The valve lash settings received verification and adjustment after initial heat cycling. The thermal expansion brought clearances closer to optimal specifications, but individual adjustments ensured perfect valve timing. Each cylinder received individual attention, Walter rotating the engine manually while adjusting lash with feeler gauges and wrenches. The cooling system performance required evaluation under sustained load conditions. Walter operated the engine at elevated speeds for extended periods, monitoring coolant temperatures while ensuring adequate heat rejection. The radiator capacity proved marginal, prompting the addition of supplemental cooling through a secondary heat exchanger. The lubrication system similarly needed validation. Oil pressure at various engine speeds confirmed adequate supply to all components. Walter sampled the oil periodically during the break-in period, laboratory analysis revealing the presence of break-in metals in quantities suggesting normal wear patterns rather than catastrophic problems. After weeks of patient tuning and break-in operation, Walter prepared for the ultimate validation, a full-power test run. The engine had demonstrated capability across moderate speed ranges, but verifying the targeted 900 horsepower output required sustained operation at maximum intensity. The risk was considerable, any component weakness potentially causing catastrophic failure. The shop received modifications to safely contain the test. Heavy sound-dampening curtains hung from the ceiling, protecting Walter's hearing during the screaming assault. Additional ventilation exhausted fumes that would otherwise become overwhelming. The engine mount received reinforcement, the stand welded to floor-mounted plates that prevented any possibility of movement. Walter invited several witnesses for the attempt, fellow enthusiasts who appreciated the significance of what was about to unfold. They arrived carrying cameras and recording equipment, eager to document the mechanical spectacle. The atmosphere carried nervous energy, excitement tinged with awareness that years of work faced validation or destruction within the next few minutes. The pre-test inspection consumed over an hour. Walter checked every fastener within reach, verifying torque specifications and looking for any signs of loosening or stress. The fuel system received pressure testing, confirming no leaks existed at the elevated pressures demanded by maximum power operation. The cooling system was topped off, every passage bled of trapped air that might create hotspots. The electrical connections underwent continuity verification, ensuring sensors would provide accurate data throughout the test. The instrumentation for this attempt had been significantly expanded. In addition to the basic gauges, Walter had installed data logging equipment that would record dozens of parameters simultaneously. Exhaust gas temperature sensors monitored each cylinder bank individually. Vibration sensors attached to the block would detect unusual mechanical activity. High-speed cameras positioned at strategic angles would capture the visual spectacle while potentially revealing problems invisible to human observers. Walter reviewed the test protocol one final time with his witnesses. The engine would warm to full operating temperature at moderate speed before advancing to maximum power. The full power run would last 30 seconds initially, sufficient to verify performance without unnecessarily extending risk exposure. If that run succeeded without problems, a second 60-second run would follow, demonstrating sustained capability. Emergency procedures were reviewed, everyone understanding their responsibilities if catastrophic failure occurred. The starting sequence proceeded smoothly, the V12 firing immediately and settling into its now familiar idle. Walter allowed 20 minutes for thorough warm-up, watching temperature gauges climb gradually toward normal operating ranges. The oil pressure remained rock-solid, the cooling system maintaining appropriate temperatures without difficulty. All indicators suggested readiness for the ultimate test. The throttle advanced gradually, engine speed climbing through the moderate range where countless hours of tuning had occurred. The sound intensified correspondingly, the mechanical symphony building toward its crescendo. At 1,800 revolutions per minute, Walter paused, allowing the engine to stabilize while he verified all parameters remained within acceptable limits. Everything looked perfect. The throttle continued advancing, engine speed climbing into territory rarely explored during the tuning phase. At 2,000 revolutions per minute, the turbochargers reached full effectiveness, their contribution transforming the engine's character dramatically. The boost pressure climbed rapidly, compressed air flooding into cylinders already receiving supercharger output. The fuel system responded to increased demand, injectors delivering precisely metered quantities at pressures exceeding 20,000 psi. The sound became almost unbearable despite the hearing protection everyone wore. The distinctive two-stroke scream reached levels that seemed impossible from mechanical sources, the exhaust note a continuous roar punctuated by the supercharger's rising shriek. The turbochargers contributed their own high-frequency whine, the combined acoustic assault overwhelming every other sense. At 2,200 revolutions per minute, Walter held the throttle steady, allowing the engine to demonstrate sustained operation at near maximum output. The data logging equipment captured everything, digital records preserving information faster than human perception could process. The exhaust gas temperatures peaked around 1,400 degrees Fahrenheit, hot but within acceptable limits for short-duration operation. The boost pressure stabilized at 32 psi, slightly above the target but not dangerously so. The power was staggering even without precise measurement. The reinforced engine stand transmitted massive forces into the floor mounting, the entire structure vibrating despite its substantial construction. The building itself seemed to resonate sympathetically, windows rattling and loose items dancing across work surfaces. The air moving through the engine created a physical presence, the intake suction audible as a roaring howl that combined with the exhaust cacophony. Walter maintained maximum power for 30 seconds exactly, then began throttle reduction. The engine speed decreased gradually, the mechanical violence subsiding as fuel delivery diminished. The turbochargers spooled down from their screaming peak, exhaust energy declining as engine output decreased. Within seconds, the V12 returned to moderate speed, the comparison to the previous intensity making the reduced output seem almost peaceful. The initial assessment suggested complete success. No unusual sounds had emerged during the run, no warning lights had illuminated, no gauge readings had entered dangerous territories. The engine continued running smoothly at moderate speed, showing no signs of damage or distress from the brief but intense workout. Walter exchanged glances with his witnesses, seeing his own cautious optimism reflected in their expressions. The inspection that followed consumed another hour. Walter examined every visible component while the engine cooled, looking for any signs of problems. Fasteners remained tight, no leaks had developed, no cracks appeared in stressed components. The exhaust pipes showed appropriate coloring, the metal oxidation patterns confirming proper air-fuel ratios. The turbocharger bearings rotated smoothly when manually turned, suggesting they had survived the extreme speeds demanded during maximum boost. The data analysis revealed impressive results. The calculated power output, derived from fuel consumption and air mass flow measurements, suggested the engine had produced approximately 875 horsepower during the test run. While slightly below the 900 horsepower target, the figure represented extraordinary achievement for a naturally aspirated diesel configuration enhanced by relatively modest forced induction. Additional tuning might extract the final 25 horsepower, but the current performance already exceeded most reasonable expectations. After allowing sufficient cooling time, Walter initiated the second test run. The protocol matched the first attempt but extended duration to 60 seconds, demonstrating the engine's capability for sustained high-output operation. The warm-up proceeded efficiently, the engine reaching operating temperature more quickly than before due to residual heat in its massive thermal mass. The throttle advance followed the previous sequence, engine speed climbing steadily toward maximum. The acoustic assault resumed its earlier intensity, the mechanical scream building until conversation became impossible even through shouting. Walter monitored the gauges intently, watching for any divergence from the patterns established during the first run. The 60-second duration felt eternal while simultaneously passing instantaneously. Walter maintained unwavering focus on the instrumentation, ready to abort immediately if any parameter ventured toward dangerous territory. The engine performed flawlessly throughout, every system functioning precisely as designed. The exhaust temperature remained stable rather than climbing progressively, confirming adequate cooling capacity. The oil pressure held steady, demonstrating the lubrication system's ability to maintain protection under sustained demand. The throttle reduction after 60 seconds brought palpable relief mixed with triumph. The engine had demonstrated sustained capability at power levels that challenged credulity. Walter shut down completely after several minutes of cool-down operation, allowing the engine to rest after its extraordinary exertion. Silence returned to the shop gradually, hearing recovering slowly from the acoustic assault. The smell of hot metal and diesel exhaust hung thick in the air, a perfume that Walter found intoxicating. The post-test inspection revealed no problems whatsoever. The engine had tolerated maximum output without any component failures or concerning wear patterns. Walter changed the oil immediately, sending samples for laboratory analysis that would reveal any microscopic damage indicators. The results returned days later showing completely normal composition, no excessive metal content or combustion contamination that might suggest problems. The final power verification occurred through arrangements with a performance facility several hours away. The shop operated a sophisticated engine dynamometer capable of precisely measuring output across the entire operating range. Walter transported the V12 carefully, the engine secured to a custom-built transport stand that facilitated installation on the dynamometer. The dynamometer testing proceeded across multiple sessions, technicians methodically exploring the engine's characteristics while recording comprehensive data. The power curve showed impressive breadth, substantial torque available from low speeds climbing to the peak output at higher RPM. The maximum measured power reached 893 horsepower at 2,250 revolutions per minute, accompanied by 1,340 lb-ft of torque at 1,950 revolutions per minute. The figures validated Walter's accomplishment beyond any doubt. The efficiency measurements revealed surprising results. Despite the engine's age and two-stroke design, the specific fuel consumption figures compared favorably to many modern diesel engines. The careful tuning had optimized combustion sufficiently to extract impressive efficiency from the basic thermodynamic cycle. The emissions, while certainly not meeting current standards, remained reasonable for such a high-output configuration. The durability assessment involved extended operation at various loads, simulating real-world usage patterns that might occur in marine or industrial applications. The engine tolerated everything without complaint, temperatures and pressures remaining stable throughout hours of sustained operation. The dynamometer operators expressed genuine admiration for the restoration quality and performance achievement. Back in his shop, Walter stood before the completed V12, reflecting on the journey that had transformed corroded abandonment into screaming magnificence. The months of effort represented more than mechanical restoration. They embodied a philosophical statement about preservation, capability, and the enduring value of engineering excellence. The engine would never see practical application in any vehicle or vessel. Its thirst for fuel and disregard for emissions regulations made it unsuitable for modern use. Yet its value transcended utilitarian considerations. The V12 represented a mechanical sculpture, a functional art piece that demonstrated what dedicated craftsmen could achieve when pursuing passion rather than profit. Walter had documented the entire restoration meticulously, thousands of photographs and detailed notes creating a comprehensive record. He planned to present the work at enthusiast gatherings, sharing knowledge with others who appreciated mechanical preservation. The educational value might inspire future restorations, preventing other significant engines from succumbing to scrap dealers and demolition. The financial analysis revealed the project had consumed more resources than initially estimated, though not catastrophically so. The parts, machine work, and miscellaneous expenses totaled a substantial sum, but Walter considered the investment worthwhile. The intangible rewards, the problem-solving satisfaction, the accomplishment pride, the preservation of engineering heritage, justified any monetary considerations. The physical toll had been significant. Walter's 72-year-old body had protested the heavy lifting, awkward positions, and long hours demanded by the restoration. His hands showed fresh scars alongside the accumulated marks from decades of mechanical work. His back ached perpetually, the chronic pain a reminder that age eventually limits physical capability regardless of mental determination. Yet the satisfaction eclipsed any discomfort. Walter had proven to himself that experience and determination could overcome seemingly insurmountable challenges. The abandoned V12 that others had written off as worthless scrap now represented a functioning monument to mechanical excellence. The screaming demon lived again, its voice declaring victory over time, neglect, and doubt. Word of the restoration spread through enthusiast communities rapidly. Walter received visitors regularly, fellow diesel fanatics making pilgrimages to witness the resurrected V12. He welcomed everyone graciously, conducting tours that explained the restoration process while demonstrating the engine's capabilities. The shop became an informal museum, a place where mechanical heritage found appreciation and preservation. Several organizations approached Walter about displaying the engine at exhibitions and shows. He agreed selectively, transporting the V12 to events where it would receive appropriate recognition and inspire similar preservation efforts. The engine's demonstration runs became legendary, the screaming performance invariably drawing crowds and capturing attention that helped promote diesel engine appreciation. A marine restoration specialist contacted Walter about potential collaboration. The specialist had acquired a vintage vessel requiring period-appropriate propulsion, and the Detroit Diesel V12 would provide both historical accuracy and impressive performance. After extensive negotiations, Walter agreed to sell the engine with the understanding that it would receive proper installation and continued preservation. The financial return would fund future restoration projects while ensuring the V12 would achieve its intended purpose of propelling a vessel through water. The preparation for the engine's departure involved mixed emotions. Walter had invested so much effort into the resurrection that separation felt bittersweet. Yet seeing the V12 destined for active service rather than static display provided satisfaction. The engine would fulfill its design purpose, generating power while demonstrating the enduring capability of classic American engineering. Before the transaction finalized, Walter conducted one final test run. He wanted to experience the Screaming Demon's full fury one last time, creating a permanent memory that would endure regardless of future separation. The engine fired immediately, settling into its familiar idle before advancing to maximum output. The mechanical scream filled the shop with sound that Walter felt as much as heard, the visceral experience creating sensory imprints that would never fade. As the engine cooled after the final run, Walter cleaned it meticulously, removing every trace of oil and dust. The V12 gleamed under the shop lights, chrome components polished to mirror finishes and paint surfaces restored to showroom condition. The transformation from corroded abandonment to pristine excellence seemed almost impossible when reviewing the initial documentation photographs. Yet the evidence stood before him, undeniable proof that dedication could overcome any challenge. The marine installation proceeded months later, Walter traveling to observe the process and ensure proper integration. The vessel's engine compartment accommodated the massive V12 perfectly, almost as though the space had been designed specifically for this power plant. The mounting and alignment consumed days of careful work, precision essential for reliable operation and vibration control. The first voyage occurred on a brilliant spring morning, perfect weather providing ideal conditions for the maiden run. Walter joined the crew, unwilling to miss witnessing the V12 performing its intended function. The engine started immediately, the familiar sound muffled somewhat by the vessel's engine room but still unmistakably the Screaming Demon he'd resurrected. The vessel's departure from the dock proceeded smoothly, the propulsion system responding precisely to throttle inputs. As open water appeared ahead, the captain advanced power gradually, the V12's output driving the vessel to impressive speeds. The performance exceeded expectations, the classic engine demonstrating that properly maintained mechanical systems could rival modern equivalents. Walter stood on deck feeling the wind and spray, listening to the muffled roar from below. The satisfaction of seeing his work achieving practical purpose brought emotions that threatened to overwhelm his customary stoicism. This moment represented the culmination of everything: the accidental discovery, the extraction challenges, the endless hours of restoration work, the breakthrough when the engine first fired, the tuning refinement, the power verification, and finally the installation and successful operation. The Screaming Demon had found its voice again, and that voice now propelled a magnificent vessel across the water. The engine that had sat abandoned and forgotten for decades now contributed meaningfully to human activity, its mechanical excellence providing value while demonstrating historical preservation's importance. Walter knew that his role in the resurrection would remain a source of pride for whatever years remained to him. Back in his shop, Walter began organizing documentation from the V12 restoration. The photographs, notes, measurements, and technical records would become a comprehensive guide for anyone attempting similar preservation work. He planned to compile everything into a detailed manual, sharing knowledge that might prevent other significant engines from permanent loss. New project possibilities already occupied his thoughts. The warehouse demolition had been postponed, providing additional time for salvage operations. Walter had identified several other engines during his initial exploration, including what appeared to be a rare radial aircraft power plant and a massive industrial gas engine. Either would present challenges comparable to the V12, demanding similar dedication and expertise. At 72 years old, Walter understood that time was finite. Each major restoration consumed months or years, and the physical demands increased as age progressed. Yet retirement to passive activities held no appeal. The shop represented his identity, mechanical work providing purpose and satisfaction that couldn't be found elsewhere. As long as his hands maintained capability and his mind retained sharpness, he would continue resurrecting abandoned machines. The Screaming Demon's legacy extended beyond its own resurrection. The project had demonstrated that seemingly impossible challenges yielded to patient effort and appropriate expertise. Younger enthusiasts who witnessed the work or learned about it through documentation might feel inspired to attempt their own preservation efforts. Each rescued engine represented more than mechanical restoration. It preserved engineering history and maintained connection to eras when craftsmen built machines intended to last generations. Walter turned off the shop lights that evening with characteristic satisfaction. Tomorrow would bring new challenges and opportunities, continuing the endless cycle of discovery, problem-solving, and accomplishment that defined his existence. The empty engine stand where the V12 had sat for months now waited for its next occupant, ready to support whatever mechanical challenge Walter decided to tackle next. The old mechanic had proven beyond doubt that he could resurrect a 900-horsepower Screaming Demon. The question now was simply, what remarkable machine would he discover next? Before we wrap up this incredible journey of mechanical resurrection, I want to extend a massive thank you to everyone who watched until the end. This channel is so close to hitting 6,000 subscribers, and reaching that milestone would be absolutely incredible. If you enjoyed following Walter's amazing restoration of this legendary V12 Detroit Diesel, please hit that subscribe button right now. It takes 2 seconds and means the world to this channel. And if you really want to support detailed, long-form content like this, consider leaving a super thanks. Every contribution helps me continue creating these in-depth mechanical documentaries that celebrate engineering passion and preservation. Also, I'm genuinely curious. Where in the world are you watching this from? Drop a comment with your location. I love hearing from fellow enthusiasts across the globe, and it's amazing to see how this passion for mechanical excellence connects people from everywhere. Thank you again for watching, and I'll see you in the next one.